In this video, we'll go over some practical questions involving Newton's laws of motion. So we'll go over some Newton's second laws of motion, Newton's third laws of motion, and first laws of motion. Then we're also going to do tension forces, Pulley system, contact forces, elevators, incline plane. Yeah, so we want to see and want to know how we can solve any questions involving Newton's laws of motion. How can you solve a question involving elevators? How can you solve a question involving Pulley system? So by the end of this video, we are supposed to know how to calculate or to solve any questions involving Newton's laws of motion. Okay, so the first question which we are going to deal with is what you can see there. Number 1, a 6.0 kgs object undergoes an acceleration of 2.0 meters per second squared. This one is supposed to be meters per second squared. Yeah. Then part A, what is the magnitude of the resultant force acting on it? Part B, if this same force is applied to a 4.0 kgs object, what is acceleration produced? Okay, now first thing in physics, what we need to understand is that before you solve any question, come up with the free body diagram. So the free body diagram is going to help us to calculate this, to calculate the resultant or the magnitude of this force and the acceleration. Okay, there we go. So our free body diagram, from this case, we can just come up with something like this to say this is the surface and our object is there, and we are going to assume that this object was moving in this direction. So you apply a force. We don't know that force is the one which you want to calculate, and this object has got 6.0 kgs as mass, and it was moving in this direction with an acceleration of what? 2.0 meters per second squared. Now part A, after coming up with the free body diagram, let's now see. Part A is saying what is the magnitude of the resultant force acting on it. We know that according to Newton's second law, the F net, or say force, is going to be given by what is the force acting in this object. It's just the force, the same force, which is the applied force, or we can call Fm if you want, so that we say applied force. So what we are supposed to understand is that when there is acceleration, there is a net force. So if there is net force, where there is net force here, we are supposed to replace with what? Mass times acceleration. So I'll say mass times acceleration is going to be given by my applied force. My goal is to calculate the applied force. Okay, I know the mass. The mass is 6.0 kgs times, I know the acceleration, 2.0 meters per second squared. I have my applied force. So if I get my calculator and I punch, I'll be able to get 12 newtons. That will be my applied force. So this is the answer for part A. What of part B? Part B is saying if this same force is applied to a 4 kgs block or object, what is the acceleration produced? So the same force, we have calculated the force. They are saying the same force, now it is acting on what? 4.0 kgs, but the same force which we have calculated, which is 12 newtons, and we don't know the acceleration. Well, let's calculate the acceleration. We know that force is going to be given by mass times acceleration. We know the force is 12, and we know the mass is 4.0. We don't know the acceleration. Let's divide both sides by 4. Both sides by 4. We get our acceleration as 3.0 meters per second squared. That is the answer for part D. So the best thing is, let's come up with the free body diagram. After that, then let's now start solving the question. Okay. Number 2, as a fish jumps vertically out of the water, assume that only two significant forces act on it: an upward force F exerted by the tail fin and the downward force due to gravity. A liquid tinoxone has a length of 1.50 meters and a mass of 61.0 kgs. If this fish is moving upward at an acceleration or at the velocity of 3.00 meters per second, as its head first break the surface and has an upward speed of 6.00 meters per second after two-thirds of its length has left the surface. Assume constant acceleration. Determine A, the someone's acceleration, B, and the magnitude of the force during this interval. The first thing we need to understand is that we need first to come up with the free body diagram. So, if this was the surface, okay, then let's say here, inside here is what? There is water. Now, inside the water, there is a fish. Okay? And according to the statement, it is telling us that this fish, the length of this fish, the total length of this fish is what we have been given there. Is here 1.50 meters. The initial velocity. So let's come up with data. We have our initial velocity as we have been given 3 meters per second. We have our final velocity as what? As 6 meters per second. What else do we have? Okay, we also have the mass of the fish as 61 kgs. Then we can come up with, say, according to Newton's second law, the F net is going to be given by ma. Okay, so now we don't know the acceleration. We can't calculate the magnitude. Now first we need to come up with the acceleration. That's when we can calculate the what? The magnitude now. Okay, now since part A is asking about acceleration, now it is saying this fish immediately after breaking the surface here, going up outside, the portion which was outside, it was just 2/3 of its length. So what is 2/3? 2/3 is 2/3. So what is 2/3 of 1.50? You are going to calculate this and we are going to find that is 1 meter. So meaning, when now this fish was outside, let me write it from that other side. Okay, when now this fish is outside, only 1 meter of it was what? So this is water. Now the fish is there. Now the fish has just come out. So out of 1.5, only 1 meter is outside, and the total length of the fish remains the same as 1.5. Now we can see that we now have the distance as our our distance we have now as 1 meter. Now the question is, we need to calculate the acceleration. Which formula can we come up with? We have this data, we calculate the acceleration. Okay, as we can see, the only formula which we can use, since we don't have time, it is the third formula, which we know that v squared has to be equal to v initial squared plus 2ad. Okay, so v squared, we know that our initial or our final velocity is 6 squared. The initial one is 3 squared plus our 2. Then acceleration we don't know. The distance we know it, so the distance is 1. Okay, so we know that this one is going to give us 36. Then I'll shift this guy to the other side. It's going to be minus 9, has to be equal to 2a. So what is 36 minus 36 minus minus 9? We should get 36 minus 9, 27. I'm getting 27. 27 has to be equal to 2a. Let's divide both sides by 2 by 2. So my acceleration is going to be equal to, divided by 2, I'm getting 13.2 meters per second squared. That is the answer for part A, because it is asking us to calculate the acceleration. But what of B, the magnitude? We have already come up with the formula here. This is our formula. Now, if this is our formula, guys, we know the acceleration now. So we have said that is our formula, mass times acceleration. Okay, so we don't know the force is the one we want to calculate. We know this one is 61 times the acceleration is 13.5. So my magnitude will be 13.5 times 61. Okay, so our mass was 61, yeah, so it's 61 times. Okay, but before we go there, we have said that this is the force, this is the formula which we need to use. Let me first get rid of this before we even start. That is F. So now let's check. This is the fish. Now the question here was saying we need to ignore, there's a part it was saying we need to ignore something here. A fish jumps out, what, so we have got the upward force. There's a force which is going in that direction. Okay, so we can call that force. Then since we know that we are going to have the weight of the fish, which is mg, okay, so that is the forces which we have. So if we can come up with the formula to say the F net is going to be equal to, what are the forces acting in this case? We have got the force minus, it has to be minus the weight force, because this force is going up and then weight force is in short, the weight force is trying to bring the fish down again in the water. So we are going to do minus the mg. So since I don't know the m, this one where there is F net, we are going to replace with m times a, has to be equal to the applied, that upward force, minus mg. I want to calculate the upward force in short. Okay, so if I want to calculate the upward force, what should I do? I'm going to shift this one to the other side, and I'm going to have now my F as ma plus mg. Then if I plug in the values, I know that the mass is, if I want, I can just isolate m. I say m, a, then g. Okay, I think that one is, it can help us. Then now from there I'll say F is going to be given to, my mass is 61. Okay, so if my mass is 61, what of my acceleration? My acceleration is 13.5 plus my g is 9.8. Okay, so if I get my calculator here, I'll be able to get 13.5 plus 9.8. Okay, now that times 61. Okay, I'm getting 1421. 1421.3 newtons. So this is the answer. Okay, so basically we need just to understand the concept, the question. If you understand the question, nothing is difficult. You come up with the free body diagram, then now come up with the data that is going to help you to calculate any question in physics. Okay, let's go to the next question. So next question leads, it's saying a person has a reasonable chance of surviving a car crash if the deceleration is no more than 30 Gs. Then in brackets we've been given the G is 9.8 meters per second squared. Calculate the force on 70 kgs. We are saying calculate the force on 70 kgs person undergoing this acceleration. What distance is traveled if the person is brought to rest at this rate from 100 kilometers, from 100 kilometers per hour? Okay, first we need to understand the question again. That is very important. Without understanding the question, we can't get anything. That is what we need to understand. So maybe the first part is confusing you, to say a person has a reasonable chance of surviving a car crash if the deceleration is no more than 30 Gs. So 30 Gs is just acceleration. To say 30, it's just telling you to say it is acceleration. So that acceleration, it is the same as 30 times 9.8 meters per second squared. So we do just 30 times 9.8, that will be our acceleration. Okay, so if we do that, then we should be able to get 294 meters per second squared, meaning this is our acceleration. At the same time, we know the mass. The mass, we have been given that the mass is 70 kgs. Okay, now if we know the mass, part A is asking us to say calculate the force. So we know that force is mass times acceleration. So mass, we know it already, that is 70, times acceleration, again we know it, that is 294. So my force let me get my calculator. So 70 times 9 point that times 294, we should be able to get 2580 newtons. Okay, so the good part, the good idea which you can do, guys, is you pause the video and solve at your own. Like, you solve yourself, then you solve the question, then you see if you are getting the same answer as the one I'm getting here. Okay, so I'm getting 20,580 newtons. That is part A. Part B, what distance is traveled if the person is brought to rest at this rate from 100 kilometers per hour? So the first thing we need to understand here is this. We need first to change this guy, because we know that our answer is supposed to be in meters. Okay, our answer is supposed to be in meters per, or in meters in short, because we are calculating the distance. So that we have 100 kilometers per hour. I need to convert that one into meters per seconds. So first of all, if you have not watched my video under units and measurements, or measurement and units, you can go back and watch the video so that you know how to convert the units. Okay, so we know that if I want to convert that one, I know that in 100 or in 1000 meters we have got 1 kilometer. So now I'm setting the units in such a way that they should cancel each other, meaning this guy and that guy, they'll go. Our target is to get meter, and we're done. Let's now go there. In 1 hour, how many seconds do we have? So in 1 hour we have got 3,600 seconds, meaning hour and hour will go. Now let's do the math. The 2 0 can go, the 2 0 can go. Then you have got 1000 divided by 36. We should be able to get our that velocity as what? As if I get my calculator, I do that one divided by that one. I'm getting 27. I'm getting 27.8 meters per second. That is my initial velocity. Now, which formula we have? Let's correct our data again once more. If we can do that, let's have data. Data is going to help us to know which formula should we use. So our data, we have got our initial velocity as 27.8 meters per second. We have our acceleration as 294 meters per second. What else do we have? Now, immediately when this person is brought to rest, the deceleration, as we can see there, what are we supposed to do? Since we are talking about deceleration, the deceleration, meaning the acceleration is supposed to be negative. Immediately when you hear the word deceleration, acceleration is negative. Okay, that's what we know, and we don't know change in x. That is what we want to find, the distance. What else? So if something is starting from here, from this point up to point B, then it is decelerating to this point to there, meaning the initial velocity you are going to have, the final velocity, since it's going to go to rest, the final velocity is going to be 0. So we have all the information there. Which formula do you think we can use? The only formula which we can use is v final squared plus the formula is supposed to be v final squared, then v initial squared plus 2a change in x. This change in x is the same as s, is the same as distance, same as height. Now, when we are dealing with the motion in x direction, we will present it what? X. If you want, you can say s. If you want, you can say d. No one is going to penalize you. Okay? But sometimes I can recommend you to say, if maybe you say change in x, then tell to say x represent what? Distance. So that the one who is going to be marking should know what you're talking about. Okay? If you say s represent what? Distance. Okay, so there we go. The initial is going to be 0 squared. There, the final, or the initial, sorry, the final 0, the initial, we have 27.8 squared plus 2. Our acceleration is negative 294. Change in x is the one we want to find. Shift that guy to the other side. So if we are to do that, we are going to have negative 27.8 squared has to be equal to negative, if I get my calculator, say neg 294 times 2, I'm getting negative 588, negative 588 times change in x. Let's divide both sides by negative 588, negative 588. Okay, and we are going to find that our change in x is going to be equal to, if we divide, that one is squared, so don't forget, I'm getting 1.31 meters. So that was our distance. Okay, next question. Okay, next question is saying the leg and cast weigh 220 newtons, that is W1. Determine the weight W2 and the angle alpha needed so that no force is exerted on the hip joint by the leg plus the east. Okay, plus the cast, sorry. Now first of all, we have the free body diagram here. Nothing is complicated. So we have been given that this guy is what? Is 220 newtons. At the same time, we know that this guy, like, it was applied at an angle. So as we can see, we can also, let's just make things simple here. We are going to call this one as W3, since we have got W1, W2 and W3. So I'm going to extend this. Okay, then I'm going to do that. Okay, meaning this guy 110, this one has got the x component and the y component. Even same applies to feet, has got this W2 has got the x component and the y component. But let's call these guys, let's just call them as what? I want us to call them as, since we have considered that we have W there, let's call them as we say that this one is going to be W3y, that component. Then this one, let's call it W3x. This one is going to be W2x, W2y. So we know that we have done vectors. That is the same as we have this. Okay, and we have our alpha there. So alpha is the same as theta. So we have our W here too. So we want to find this guy. So this guy, we know that it's going to be the same as the opposite. This one opposite is y to y. Then this one adjacent is y to x. So using SOHCAHTOA, this one is going to be our x. Our x value is going to be y2 cos theta, then, or I can say cos alpha. Okay, cos alpha. Then that one y1 is going to be y2 sin what? Sin alpha. So this one is that one, then that one is that other one. So same applies to that other one. It's the same thing. We're going to apply those. So we can just write them here. y3y is going to be y sin theta, and we also know that our y is 110 sin 40. I'm now talking about this. I'm now here in this guy. Okay, so therefore our y w y is going to be, what is 110 sin, that is 40, not just 40, sin 40. I'm getting 19.10. Okay, what of y, okay, what of y 3x? It's going to be y cos theta, and it's going to be, our y is 110 cos angle, which is 40. Then you're going to get 110 cos what? Cos 40. I'm getting 84.26. Okay, now what we need to understand that this object doesn't move, like it is at equilibrium. So when something is at equilibrium, meaning we need to get all the forces acting on it. As we can see, we have got the forces in y direction and the forces in x direction. Okay, then that other one is the same as this one is going to be, you can use the different color. This one is going to be y2 cos alpha. This one is going to be y2. I don't think you can be able to see with that color. Okay. Okay, so okay, here let me use the red one. This one I've said is 220. So this one is going to be y2 cos alpha. This one y2 sin alpha. So now the forces acting on that object, let's start with the forces in y direction. Since it is not moving, the net force, we don't have acceleration, the net force is going to be 0. So the forces acting in x direction, we have what? We have this force going in this direction, so it's going to be positive. So we have said that that one is going to be y2 cos alpha. This one is going in this direction, so it's going to be negative. And we have already calculated that one as y3x. This one we have already calculated. So without wasting our time, let's just put minus 84.26. Okay, now after that we know that this one is going to give us 0. We are going to put 0 there. Then I'm going to shift the same 84 to the other side. Then I'm going to have my y2 cos theta minus, oh sorry, is equal to, this one now has to be shifted to the other side. It's going to be 84.26. So since I want to find yw or w2 and alpha, so I have got two unknown values, meaning I need more equation for me to find those values. Okay, so now if that is the case, then what should we do? Let's find another equation. Let's call this one as equation 1. Let's go to the another guy. We also have the forces in y direction. So the forces in y direction, what are the forces? We have got the force, this force as y, which is y2 sin theta. y2 sin theta. It is sin alpha, sorry. It's supposed to be sin alpha. It is going in positive y, that's why it's positive. Even the y3y, that one, we have already calculated that is c, so it's going to be plus 190 what? Oh, 19, sorry, 19.10. Yeah, so that 19.10, as we can see, or maybe we made a mistake. Let me punch again. 110. We said 110 sin 40. Okay, I'm getting 70. I'm getting 70.71. Okay, so that one we said it was 110. Let's redo again. I don't know, 110 sin 40. Okay, so this one was supposed to be 100. Oh, it's 70, sorry. It's 70.71. Okay, so that is what we are going to have there now. As we can see here, since it is also going up, without wasting our time, instead of us plugging to say y2 sin theta, since we know the value, we have already come up with those, so it's going to be 70.71. Now since we also have another, this guy is weight force going down, w1, so it's going to be minus now 220 newtons. That is the w1. Since this guy is alone, we can shift this guy alone to the other side. At the same time, or let's just, since we have the number, this one is going to be 0, we have w2 sin alpha. Since these are numbers, we can just add them, right? So we have got 17.71 minus 220. So I'm getting minus negative 149.3. Okay, I shift this guy to the other side, is going to be y2 sine theta has to be equal to 149.3. I can call this one as my equation 2. Now when you have got two equations, you have got sine and the cos. Put the equation which has got sine on top and divide by the equation which has got what? Sine. So like in this case, we have the third equation, or the second equation has got it. So we have got this equation which has got sine. We have got 2 sine, although this one is on alpha, sine alpha is equal to 149.3. You divide that guy which has got sine with him, the one with cos now. Cos what? Cos alpha has to be equal to 84.26. Let's now divide. We know that W2 will go, they will cancel each other. Okay, so they will cancel each other. Then we are going to have that sine over cos is tan. We are going to have tan alpha. That when we divide that one, we are supposed to get 1.77. Yeah, my calculator here is giving me 1.777173. Now if you want to find the theta, you say theta is going to be equal to tan inverse, open brackets, 1.77173. So let's see what will be our alpha. Sorry, yeah, I'm used with theta. So our alpha is going to be, if I get that one, I say shift tan, and I say 1.77173. I'm getting 60.55655, which is the same as alpha is equal to 61 degrees. So since we have found that one, now we need to find the, we have found the what? We have found the theta. So we have got two equations. We are going to get one equation. If you want, you can use any. You are going to find the same answer. So I'm going to use this one. Okay, we have found that one, so I'm going to use that one. I'm going to use, we have got y2 cos alpha has to be equal to 84.26. So since we have the alpha, so it's going to be w2 cos c 61 has to be equal to 84.26. I divide both sides by cos c 61, both sides by 60, or cos 61. My w2 is going to be given by, if I divide that one, 84.26 divided by cos what? Cos 61. We have 173. Okay, we have 173.8 newtons. So that is the answer for this question. That's how you solve this question. The first thing, come up with the free body diagram, resolve those the forces which you have into y and x component when you have got the forces. Then now get the summation of the forces in y direction at the same time in x direction. Then now if you have got two unknown values, since you have got two equations, one equation is going to help you to calculate the other one. Okay, yeah, so that's what you do. Okay, next question is under Pulley system, and the question reads: the two masses in the figure 4.14 are tied up to opposite end of massless rope, hung over and or a massless and frictionless pulley. Find the acceleration of the mass. The device is called an outward machine. So the question is only asking us to find the acceleration of the masses. So we are going to also to calculate, let's include the b to say find the tension, or what is the tension in the code. What is the tension? Okay, so the first thing which you need to do is what you need to understand is this. This is the Pulley system which we have. Now, The forces, as we can see, we have got the arrows, meaning the acceleration going up is positive. So this acceleration is positive, that acceleration is negative. The system is going in this direction, meaning according to Newton's second law, we know that the F net is going to be, what are the forces making this system to go? Genuinely speaking, the force that makes that guy to go, it is the weight of M2. But again, there is another, since this one is also hanging in free, there is another force of M1 which is trying to bring the object in this direction, but it's not enough. That is the reason why it's moving in this direction. So W1. So the force is W2 minus W1. That is the force that makes the object to go in that direction. Okay? So if that is the case, we have said that this one is going to be acceleration is going to be negative, but for this one is going to be positive. Now, we know that we have got two masses. So for us to because we know that we are supposed to replace this F net with mass times acceleration, but we can't replace with only one mass because we have got two what? We have got two masses. So we are supposed to replace with the addition of masses. So it's going to be M1 plus M2. Then times acceleration has to be equal to, we know that this guy is just M2g, this one is just basically M1g. So here is same as M2g minus M1g. Let's divide both sides by M1 plus M2, then both sides by M1 plus M2. Then we are going to be able to find that the acceleration is going to be given by this formula, minus M1, okay, minus M1 G, then M1 plus M2. So let's plug in the values. We have got M2 as what? We have got M2, we have been given the mass 1 as is there, or mass 2, sorry. Mass 2 is 10, so we have 10 times 9.8, put them in brackets, minus mass 1 is 5 times 9.8. We divide both sides by 10 plus 5. Okay, so we go there. Let's now see. It's going to be 10 times 9.8, which is 98, minus 5 times 9.8. I'm getting 49. So 49 divided by what? 15. I'm getting 3.27 meters per second squared. So that's how you find the acceleration. Okay, there are two methods which you can use to calculate to resolve such kind of question of Pulley system. If you want to check another formula, you can watch my video which I just posted. Okay, it's under Pulley system. You check it, you're going to see the formulas. I explained about the formulas, two formulas, but here I'm just using this one, the short one. Okay, but how can you also calculate the tension? So when you want to calculate the tension, you are going to use one thing. It's either we want to get mass 1 or mass 2, but both they are going to give us the same answer. Let's see. So we're going to do both. Let's consider mass 1. If this is mass 1, there is a force going there as the tension, and the force going there as we have said is M1g. And the mass is what? We have said that the mass 1 is 5 kgs. Okay, so according to Newton's law, F net has to be equal to the forces acting there with the tension minus M1g. Tension going up positive, the weight force going down M1g. That's why it's carrying negative. So this is going to be MA. So let's specify which M are we talking about. M1A. Then T minus M1g. Let's shift T to the other side. Oh, sorry, the M1g to the other side. I'm going to have T is going to be equal to M1A plus M1g. Then my tension force is going to be, mass is the same, so I can also say M1, then I do this. It's the same. If you want, you can plug in from there, but I want us to know what we are supposed to do. So M1 is 5, open, acceleration 3.27 plus 9.8. Okay, so we are going to get 3.27 plus 9.8 and times 5. So I'm getting my tension as 65.5 or 35 newtons. That is my tension. What if I get M2? Do you think we can also get the same answer? Yes. Let's try. Let's prove now. Okay, so if we are to get mass 2, what are we going to see? Mass 2 is like this. We have got the tension going there, the weight force, which is M2G. So according to Newton's, we know that it's going to be the tension force minus M2G. Now, in this case, we have said, but it's going down. The acceleration is negative. Okay, so therefore here it's going to be minus MA. Okay, then TG. This minus is just the negative for acceleration because it's going down for M2. Then I'm going to shift this guy to the other side, so it's going to be T is going to be equal to M2G minus M2. This is M2, M2A. So since M is the same, we can say M2G minus A. Then T, let's plug in the values. We know that is 10, 9.8 minus 3 point this. Let's see. So 9.8 minus 3.27, getting that one times 10. Okay, I'm getting 65.3 newtons. So this, the other one we find 65.35. This is just approximately the same. So actually we are getting the same answers. You can use any, you're going to get the same answer. So that's how we work out Pulley system. Okay, but there's another type of Pulley system I explained in my video. You can check it out and you're going to see how we are solving that one. And the same one, maybe you don't know it. I'm talking about this kind of Pulley system. A Pulley system which has okay, which is in this, like you have this. So they can ask you to calculate the acceleration and the tension. So why the tension is the same? The tension is the same because these guys are connected in the same rope. So therefore the tension has not to change, it has to be the same. That is the reason even if you use this one, you get the same answer, that one the same answer. So you are supposed to know again how to solve this type of Pulley system with friction and without friction. I explained about that. You can check out my video. Okay. Okay, number 6. So the question reads, police investigators examine a scene of an accident involving 2 cars. Measure 75 meters long skid marks of one of the cars, which nearly came to a stop before colliding. The coefficient of kinetic friction between the rubber and the pavement is about 0.80. Estimate the initial speed of the car assuming a level load. Okay, so now what they're saying is that the question is saying is that you have this. So there is a road, or there is a car, and that is our car. We know that we have not been given the applied. We know that there is a force which was applying there, but we have been given the kinetic friction, the mu value, as Fk. So I've been given that mu is going to be 0.8. Okay. Now, since we know that we want to calculate the initial what? We want to calculate the initial speed. But here I'm going to teach you 2 methods. We can use the method of Newton's laws of motion, or we can use the method of work. Say work is equal to change in kinetic energy. Okay. So if we can use that method, then we can see that it's going to be easy for us to calculate that. Okay, so we are going to consider 2 situations. What are those situations? So those situations which you need to understand is that another one is going to be under Newton's laws of motion, and another one is going to be under work, energy, and power. Okay, so I'll explain both so that we understand. Okay, so the first one we are going to use Newton's laws of motion, which says that we know that the F, since it was in x direction, is going to be equal to mn. But now, since there is only a friction force which was acting there, so we are going to say the force which was there is going to be max. That is the acceleration, this one. What is the force? The friction force. But now we know that friction force opposes motion, therefore it's supposed to be negative, so it's going to be negative Fk. But again, we know that we know how to calculate the what? The friction force. The friction force is given by mu times the normal force, and the normal force is mg, so it's going to be mu times mg. Okay, so now we are going to put now there, we know that this one we are going to put mu times mg there, so it's going to be mx. Then we are got this one is mu times mg. We have not been given the mass. Sometimes you need to think you have not been given the mass, you need to make an equation so that you cancel out the masses. Okay, so as we can see, the mass will go, we're going to have our acceleration will be negative mu times g. So our acceleration is going to be negative 0.8 times 9.8. So we should be able to get negative 7.84 meters per second squared. Okay, now after knowing acceleration, the question is asking about initial. Let's now see the data which we have. Okay, let's see the data which we have, so that we choose we have the data. As we can see, we don't know the initial velocity, is the one we want to calculate. When something is brought to rest, the final velocity is 0. So we know the acceleration is negative 7.84 meters per second squared, and it makes sense because it was decelerating. What else do we know? The distance we have been given. The distance we have been given, that is 72 meters. So now we have our data. The moment you come up with the data, you see to say which formula should I use. So the data itself, we don't have time. We're going to get an equation which has got no time, which is v final squared is equal to v initial squared plus 2a d. We want to calculate the what? The initial. This one is 0 squared. Then we have v initial squared plus 2. Our acceleration is negative 7.84. Distance is 72. Okay, so if we are to do that, we are going to get plus, sorry, we are supposed to get there, that is negative, no, it's supposed to be negative there. In fact, let's put negative there, because of that negative which is inside there, it's going to be minus 100 and what? Okay, let me redo again. I feel like I made a mistake, but 2 times neg 7.84 times 72. Okay, I'm getting 1128.96. So I'll shift this guy to the other side. It's the same as I've got the v initial, then I've got this. Let's take the square root both sides. If I'm to take the square root both sides, I'm going to see that my initial is going to be the root of this number. So my initial velocity is going to be the root of that guy is c. It's just basically 33. Or let me redo it. 1128.96. Yeah, 33.6 meters per second. So that is our initial velocity. Okay, so that is the method which we can use for Newton's laws of motion. But what of if I can use the method for work, energy and power? Okay, so under work, energy and power, we know that work is given by change in kinetic energy. So work, you know that is force times distance. Okay, work is just basically force distance. So I'm going to replace their force d. Change in kinetic energy is the same as the final minus the initial. Yeah, final minus initial. Then I'll have this mass, again I have what? Initial squared. Again, I know that force is mass times acceleration, because why I'm doing this is that I don't have mass, so I'm going to replace where there is. But which force are we talking about? We're talking about the force of friction. So it is the force of friction is going to be mass times acceleration. So I'm going to replace this one with the mass times acceleration. Yeah, I'm going to replace that one with mass times acceleration. So if I do that, then we should be able to get mass times acceleration times d now, times d. So I know that when it comes to rest, the final velocity is going to be 0. This one is going to be cancelled, and it's going to be, we're going to have negative half mv squared. Let's do times 2 everywhere. Okay, if I do times 2, I'm going to get 2 mass times acceleration times d has to be equal to negative mv initial squared. Let's divide both sides by negative m. Then we are going to see that v initial is going to be mm, they will go, mass will go. Then I'll also have this negative, divide there, I'm going to get now negative 2ma. Oh, this one is squared, let's not forget. Then times d. Let's now see v initial is going to be negative d. Okay, now before we go there, we said that since we are talking about the friction, we said friction opposes motion, right? Yeah, that's what we said. So if friction opposes motion, meaning the negative has to do what? The negative here, we are going to have negative where there is work. We are going to ignore this negative here, because work is going to be negative, or I mean, like, yeah, negative f. So we are going to have negative there because the friction is opposing motion, so it's going to be negative, and there we are going to have negative. So negative and negative, it will be positive, so it's going to be positive 2 times mass. Oh, sorry, the mass has gone already. I'm sorry. The mass has gone already there. We don't need mass. Okay, we don't need mass, so we can start from there. So we don't need mass, and we are going to have v 2 ad. Okay, yeah, that's what we are going to have. So if we have that one, then what are we saying now? Okay, so if we have got that one, what are we saying? But again, we have, if we can check properly there, the friction force, or let's start from there. Let's start from here. From work done is equal to, maybe you can be confused there. Let's start from there. Let's do this. We are saying that work is equal to change in kinetic energy. So now work is the friction force. Now that friction force is going to carry negative. If we want, we can just ignore it, times distance. So we know that friction force is mu times the normal force. Okay, and the normal force is mu, or is mg. So I'm going to replace this one, we forgot mu, this one where there is f. Okay, so it's supposed to be negative now because the friction is supposed to be negative. Negative mu mg times d has to be equal to, this one is going to be half m v final squared minus half m v initial squared. Our goal is to calculate this initial. Since the final is going to be 0, we are going to cancel this. This one will go, and we are going to have mu mgd is equal to negative mu this one squared. So we can cancel the negative. At the same time, we can also cancel the mass. So the mass goes, and therefore our formula becomes mu gd has to be equal to half v, like that. Let's do times 2 everywhere. So if we were to do times 2, we are going to have 2 mu gd has to be equal to V, just like that. Let's plug in the values. 2, our mu is 0.8 times 9.8, the distance is 7 or 72 V squared. If we are to get that one, then we are going to be we will find 1128.96 V initial squared. Let's take the square root both sides, and our V initial is going to be 33.6 meters per second. So you can solve this question using two methods. The first one for Newton's laws of motion, and the other one for the other guy. Okay. Number 7. A 45 kg woman stands on a spring scale inside an elevator. The scale reads the force with which it pushes upward on the woman. What does the scale read when the elevator is accelerated upward with that acceleration, downward with that acceleration? Now, under elevators, what we need to understand is this. Under elevators, so if this is the elevator, then there is a scale inside, then there is someone there. Now, what's going to happen there is that we are going to have the weight force of this person, and with this scale is going to have the normal force. So the elevator always give you the leading of the normal force. Okay, so we are going to drive an equation. What you need to understand is that the scale doesn't always lead the weight force. That is what we need to understand. So the elevator leads the normal force. Always the elevator leads the normal force, not the weight of that object or the weight of that person. Okay, now what you need to understand is that we're going to drive an equation. So we're going to start from there. According to Newton's second law, when this guy is at rest, what you need to understand, okay, or we are going to consider to say it was going up or maybe going down, right? Let's consider to say it was going up. So in y direction, what are the forces acting? We have got the normal force, which is going up, is carrying positive, and the weight tries to bring this object down, so it's going to be negative w. Since it was moving, there is acceleration. It's going to be m a y, since it is acceleration in y direction, minus w. We know that weight is just basically mg, so I'm going to replace there. Ma is going to be fn minus mw. Let's isolate fn. So it's going to be fn is going to be given by, okay, so fn is going to be given by may plus mg. So since we're talking about the same mass, we can say m open brackets acceleration plus g. So this is the formula which you are supposed to use in any type of elevators. Okay, so from this formula now we can solve the questions. Any question, you just drive that formula and now start plugging the values. So as we can see, we have said that it's going to be reading the normal force. So it's going to be m acceleration in y direction plus g. If that is the case, let's now see the question. So what is it going to lead when it goes up with an acceleration of what? So we know the mass is 45. Acceleration up is positive, so it's going to be 3.65 plus our g is 9.8. So our fn is going to be, okay, so we have 3.65 plus 9.8, that times 45. So we should be able to get, okay, so the elevator is going to read, when it's going up, it's going to read 605.25 newtons. So that is the answer. So any type of elevators, this is what we are supposed to be doing. What if it's going down? When it's going down, the acceleration is going to be negative 3.65. But the question will not tell you that it's negative, because you know to say acceleration is a vector. So the same formula, let's see what's going to happen. If it's going down, it's going to read different things. So we are going to have 45. Now where there is acceleration, we are going to put minus 3.65 plus 9.8. So what's going to read? We have negative 3.65 plus 9.8 times 45. Okay, so I'm getting 276.67 newtons. So any type of elevators, you are supposed to do that. It's going to be reading what? The normal force, not the weight force. Okay. Next question. Two blocks with mass of m1. We have that mass attaching each other on a frictionless table. If the force F is equal to, we have been given that the force here, that is what? 6.8 newtons. Now we have been given that what is the acceleration of the two blocks. So you also come to Newton's second law. Newton's second law is going to start working here, then we are going to go to third law. So according to Newton's second law, we know that the forces acting there, we have got what? Only the upright force. Okay? But here we have got two blocks, so we are supposed to add the mass. The moment you have got two blocks, they are moving with the same acceleration. We add the mass. Then divide both sides by m1, m2, m1, m2. Acceleration is going to be equal to the upright force minus or plus this. Let's now see. This force is 6.8. Let's divide both sides by. We have got 4.1 plus 3.1. Okay, so we should be able to get. Okay, so if I punch, I'm getting 0.931 meters per second squared. That is the acceleration I'm getting for the system. Now, part B. With what force does m1 pushes against m2? Okay, so as we can see, we have found our acceleration as 0.9315 meters per second squared. So we have got as this force, according to Newton's third law now, as this guy pushes that guy, this guy also pushes this guy with the same force but in opposite direction. Okay? In opposite direction, yeah. So first, just isolate one guy. Let's get m1. If you are to get m1, what is there? There is a upright force. Okay? There is upright force which is there. At the same time, there is a force that this m2 is exerting there. Here, let me use different color. This force Fc, this one for m2 is exerting there, so we're going to have also that force. So we're going to have the upright, then we have Fc, the contact, which is that one. So according to Newton's, we're going to have the force that was there is the upright force minus the contact force that the force m2 was exerting there. Okay, so our goal is to calculate the force that this m2 was exerting there. So that is the force we want to calculate. So we know that this one is going to be mm, but which m1 has to be equal to, we know this one that is 6.8 minus Fc. So we also know the mass is 6, not 6. The mass 2 or the mass 1 is 3.2 times acceleration is 0.9193, 15 has to be equal to 68 minus Fc. So we are going to shift that other side to the other side. We're going to shift 68 to the other side, so it's going to be, if you are to get our calculator and say 32 or 3.2 times 0.9315, I'm getting 2.98 0.08 minus 68. I've shifted that guy to the other side, negative FC. So that one minus 68, I'm getting negative 65. Okay, that is what I'm getting. No, this one is 6.8, sorry, this one 6.8. So this one is supposed to be 6.8. So if I get 2.9808 minus 6.8, okay, yeah, I'm getting negative 3.8192 negative FC. Let's cancel the negative. So therefore our contact force which was there is our FC is going to be given by what? 3.81, yeah, 9 newtons. So this is the force that M2 or that M1 was pushing, or say M2 was pushing there. Okay, at the same time, the same force that M1 was pushing in that direction. But what if I want to use that M2 only? We see if we can get the same answer. We're supposed to get the same answer because according to Newton's third law, it states that the force that M1 is going to be pushing there is supposed to be the same as this force which is going to be pushing there. So let's get M2 on. The only force that is acting there on M2 is what? Is this force that M1 is exerting there. Okay, so that is what we are going to find. So we are going to find that it's going to be FC is going to be let's drive an equation. According to Newton's second law, the force acting there is just FC of M2 or M1 which was exerting on M2. So there we press 1 M2A FC. So what is our acceleration? Our acceleration was 0.9315 times the mass is 4.1. Let's see if it's going to give us that one. So 4.1 times 0.9315. Exactly, I'm getting the same one. I'm getting 3.819 newtons. So in either the case, we are supposed to get the same answer. Okay. Now, let's go to Pulley system. Pulley system, I know I mentioned everything about Pulley system, what we're supposed to do when you want to solve Pulley system. That other the video which I posted on our YouTube channel, you can check it out. So we know that what we are going to have here, the question is saying, before we even read the question, the forces acting here, we have this force and that force and that force. So we know that this force is going to be mg sine theta, and this one is going to be mg cos theta, and we know that this force, this guy is going there. So what is going to happen there is this. Okay, what is going to happen there is this. We know that Fg is always mg sine theta, and the normal force in this case is just basically mg cos theta. Okay, after knowing that, what else do we know? The question is asking to calculate the what? How much? The first question is a cartoon is given an initial speed of, so we have our initial speed there as 3 meters per second, and our theta there is just basically 22. Okay, so how far up the crane or up the plane will it go? So how far up will it go? So what we need to understand, guys, is this. What's going to happen when it's going up there is what's going to happen there is this. First of all, we need first to calculate the acceleration, and I mentioned to say we know that according to Newton's second law, it's going to be what are the forces acting there. The forces acting there, we have got only Fg that makes the object to go down. We don't have the friction force. Okay, the force that makes the system to go down is just because of Fg. And what is this guy? Since it is moving, it's going to be A ma. What is Fg? Fg is mg sine theta. Okay, mass and mass will go because they are the same. Acceleration is going to be given by g sine theta. So acceleration is going to be given by, what is our g? Our g is 9.8 sine 22. Okay, and we should be able to get 3.67 meters per second squared, our acceleration. But the question is not asking about acceleration. So now, as we can see, we have our data. Now we have our acceleration. Now we have as 3.67 meters per second squared. So what else do we have? When it comes down to the rest, the final velocity is going to be 0. Which equation can we use to calculate the time? Oh, sorry, we're trying to calculate how far, the distance. Okay, so we have that. We want to calculate the distance. What formula do we use? We have the initial, the acceleration. We want to calculate the distance. So the only formula which we can use here is the v squared has to be equal to, okay, v squared has to be equal to v initial squared plus 2a s, or let's say d. We want to calculate the what? How far, the distance. So this one is 0. This one guy is what? Is 3 squared. Acceleration, it was decelerating, so it's going to be negative. Okay, so it's going to be 2 minus 3, 6, 7. D is the one we want to find. We shift this guy to the other side, it's going to be negative 9. Then we do 2 times 2 times neg 3.67. I'm getting neg 7.34 D. Let's divide both sides by negative 7.34. Divide side by negative 7.34. Therefore, our D is going to be equal to, okay, so neg 9 divided by neg 7.34. I'm getting 1.22 or 23 meters. So that is the distance. Now the last part is asking to say how much time elapses before it returns its starting point. So if we calculate the time it takes from there, maybe from here going up, then again times 2. That is the total time for it to come back, meaning that time times 2. So we have the distance, we have everything. What formula do you think we can use to calculate the time? The only formula, the simple formula which we can use to calculate the time is, since we know the final, we know the initial, acceleration we know it, times 2. This guy is 0, this initial is 3. Since it was decelerating, acceleration is going to be negative 3.67, our t. Okay, so shift this guy to the other side, it's going to be negative 3. Let me get rid of this. Okay, has to be equal to negative 3.67 t. Let's divide both sides by 3, 7, both sides by negative 3.67. Therefore, our t is going to be equal to neg 3 divided by neg 3.67. Okay, our time is 0.81743. 86 seconds. This time is just from this point going up, but we want the time so that it takes going up again, it comes back to where it starts from. So this time which we have calculated times 2. So if I do times 2, what are we getting? Times 2, 1.6. So it takes 1.6 seconds. Okay, so that is the answer. Okay.